Hello everyone. So in this video, I'm just going to discuss the analytics, the process that I went through to do the analytics, to apply analytics in the education problem. So just to recap, so the data that you're looking at right here comes from this data set right here from UCI Machine Learning. So if you do check out some data sets from this repository right here, you'll see that the reason why they posted this data set is they were interested in looking at predicting student dropout and academic success. And the data that you see right here, it's labeled accordingly. And the data, each sample in the dataset corresponds to a student's, and it contains features that describe the student's grades for the first 2 semesters they were um, in this college and in this university. It describes the grades, the number of units that they got, and it also discusses a few features that describe the student itself, like how they applied in the university, like which order of choice was the university at, what course are they currently in, are they taking daytime or evening classes, and they also have an assessment based on their previous qualification. Like, for example, if they come from high school and they're going to this university, then they have an assessment on how that tells you how a good candidate they are. That you can find it in previous qualification grade right there, and some data according to their nationality, some data about their family, like their mother and father's qualification and job as well, and whether or not they are special needs, whether or not they're debtors, and whether or not they were taking this amount of units. So these are some quantitative variables that you would find in this data set. So the number of units credited, the number of units enrolled, the number of units approved, and it also has their grades for the first semester and the second semester. And the target is whether or not they will either drop out, enroll, they're still enrolled, or they do graduate based on they do graduate from their given program. And the researchers were interested in seeing if they can predict the students' outcome, whether or not they will graduate or whether or not they will drop out, depending on some early data on their first 2 semesters and data regarding the students themselves. So I use this data set right here because this is a good example for education, and it has a lot of data sets that you can play around with. I did do the prediction task that they're looking for, but at the same time, I also looked at some insights that I can take from the data set. And I'm going to discuss some of the few things I did to prepare this data and some of the few things I did to get the insights that I was looking for, or what insights I found from the data set instead. So if you notice, if you look at the raw data set right here, if you do download it, if you look at the values in the cells, so let me add another CSV file import. So the raw data set actually looks like this. Let me open a data table to show this one. So it only has numbers, even for the categorical data set. categorical features. So for example, gender. Let me make this full screen. So hopefully you can see this in your screens. The values that you can see are all numbers. So gender, you might expect the values to be male or female, but instead they encoded it into numbers directly, into ones and zeros. For example, nationality, which is supposed to be qualitative as well, they converted it into quantitative by encoding it into a specific number. I mean, it's still qualitative since the numbers right here don't have inherent arithmetic meaning. One doesn't mean less than two, for example. There's no ordering at the same time. So it's still qualitative, but they just encoded it, replaced it with numbers. So the first task I did for this data set was to replace all of these numerical values, all of these quantitative values with their qualitative equivalents, what categories they actually are. And from the data source right here, you can see the encoding. So for example, for this feature right here, mother's occupation. So if you see a value 0, that corresponds to the category 1. If you see a value 1, that corresponds to the category representatives of etc., etc., etc. If you see a value 2, that corresponds to specialist and etc., etc., etc. But if you want to do this in Orange data mining manually, you're going to have to do it like this. Data table, and then go to domain, edit domain. So I've shown you how to do something like this before. Basically, you take a numerical value like this one. So for example, let's look at mother's qualification, the one we saw a while ago. Let me change this first from selected data into entire data set. And then select again one of those columns, let's say mother's qualification. And if you want to change it to categorical, you just have to change it like this. So I've done this, and I've shown you examples of doing this in the data processing video. And you just have to replace this one by one with the correct meaning. So for example, 1 should be decoded into the value student. Sorry, 0 should be student, 1 should be representatives, etc. But I think there's no 0 value anywhere. So this one should be representatives of legislative power, blah, 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 etc. So just double click this value right here and then paste that value right there. And you get the replacement. It will replace every single instance of 1 into that value right there. So you're just gonna have to do that for every possible value, which can end up becoming cumbersome, especially for categories that have a lot of possible values, like this feature right here. So I ended up having to use Python myself to actually convert this data set to automatically use these encodings right here and convert them into the proper values. But if you want to achieve that without using Python, you're gonna have to do it manually like this, which will take a long time. Uh, yep, but if you know how to write Python code, then the that process will become faster since you can automate it. So it's still possible to do it in Orange. But it's not gonna take that long as well since I didn't end up using a lot of these features. So father's qualification, mother's occupation, I actually didn't end up using these features. I mainly focused on a few of these categorical variables right here and a few of these numerical value variables right here. So you might not have to do it manually for every single feature out there. Since yeah, you can just select the features that you are interested in the insights of. Anyway, so I did convert that right there, and the raw data now looks like this. So all of those numerical values right here, these quantitative values, are now replaced with these actual categories or qualities. So that's the first step that I did to process this data set right here. And the next thing that I did is to introduce some new features that I think would be interesting. So I was interested in calculating the number of unapproved units, and that right there can be calculated as the difference between the number of approved units right there minus the number of uh, sorry, the number of enrolled units, this feature right here, minus the number of approved units for that semester right there. So to calculate or to create that new feature right there, I just used the formula widget right here. And if you open this one, you'll see the formula right here. It's just calculating the difference between the number of enrolled units minus the number of approved units, and rename that new column as curricular units first sem not approved. So I was interested in that difference right there. And I also did the same for the second semester. So second semester enrolled units minus the second semester approved units. And then that difference right there, I named that feature right there as curricular units in the second semester not approved. So I added those features, and I also added the aggregates of two features. So I wanted to check the total of this one right here, the total of the first sem unapproved units and second sem unapproved units, and that's named as the total unapproved units. And to do that, you can just still use a formula, add them together as such. So if you want to use a formula, you're going to have to do it like this. New numeric variable, name that total unapproved, for example. And then the expression that you're going to use would be the sum, meaning that's curricular units first sem plus curricular units second sem, like that. And then you're going to get the sum. So press send for this one. And if I look at this data right here, should end up with a new column that corresponds to the total unapproved units, which is the sum of this plus this. 0 plus 0 is 0, 6 plus 6 is 12, etc. So let me just remove this, since this is just redundant right now because I did this using a different widget. So if you want to use this widget on the other hand, using the aggregate, so you can just select these two right here and then select the operation, the sum of these two, and then provide a name for the output variable, the output feature, the new feature that you're going to create. So the output variable is total unapproved units. And I also calculated the mean of the first semester grade and the second semester grade right there. So you can see in the label right here, aggregate the first sem and second sem grades into the mean. So to do that, select this one, and then choose the mean value for these two, and then provide the name for the new feature that's going to be created as mean grade right there. And if you look at this one, this is now my extended data. I now have all of these 4 extra features. That's unapproved units. So curricular units first sem, unapproved units for second sem, total unapproved units right here, and then the mean grade again, which is the mean of the first sem and the second sem grade. And after that, I filtered out some of the rows. I actually did that before creating these data set, these features right here. So that's why this widget is the first widget that you can see in this chain. That's actually what I did first. But to discuss there, I just basically selected the rows with enrolled units greater than 0 because I was not interested on students that didn't have any enrolled units for that semester. I just wanted to look at students who are actually enrolled in specific classes. So you see right here, I filtered out 180 of the 4,424 existing samples. So it's okay to lose just that amount since I still have 4,244 samples left over to look at. So I just used the select rows widget for that one so that I end up with rows where all of the samples have enrolled units, at least one enrolled unit for that for the first and second semester. So both of these conditions right here must be satisfied for the data to be selected. And all of those data sets right there, that's the entire data processing stage so that I end up with the extended data right here. And after that, I wanted to look at some visualizations, some of the stuff that interested me. So some descriptive insights that I wanted to check. I wanted to check the distribution of the mean grades, what it looked like. So if you open this right here, this is just a distribution visualization. And this insight basically shows that the distribution of the grades are trimodal. There are three groups. So there's a lot of students that have a mean grade for their first and second semester as 0, less than 0.5. And then a group right here where their mean grade is around 6. And a group right here where their mean grade is around 13. So the grading system that this university uses is a little bit different from ours. The grading system that they have is between 0 and 20. So this is from a university in Portugal, I believe, and they had some international students as well. So this basically tells us that there's like a specific characteristics, specific groups of students that you can form. Some students who end up having really low grades, some students who have um just in the middle, actually kind of low as well, 6 out of 20, but around there. And then some students, most of the students will belong here in this group where their average grade is around 13. 13 out of 20 is around 65%. So that's actually quite similar to the passing grade that we have in UP. So 60% is usually what a 3 corresponds to. So very interesting that the this characteristic right here, this insight can be found, which is similar to how our students look like as well. And I was interested in the box plots of the mean grades, grouping the different genders together. So here you will see box plots for the mean grade, and I wanted to compare the distributions of the male students and the female students. And this is an interesting insight right here because there's a major difference between these two groups. If you look at the distribution of male and female students, you can check that in the feature statistics right here. And go down to the gender feature right here. So there are more females than males enrolled in this university right here. And if you check if there's a meaningful difference between their mean grades, you can see that there is meaningful difference. And if you compare the median grades, so the females have a higher median grade, around 12.5, while the males have a median grade of 11.5. If you compare their means, their mean grades, the mean grades of this entire group right here, the difference is even clearer. The female students have a mean grade of 11.4, while the male students have a mean grade of 9.74. And at the same time, you can see that the dispersion is different as well because the box plot for the male students are wider right here. It goes to show that the interquartile range for the male students are also wide. So the male students have wildly different grades, while the females have similar grades around this distribution right here. So that's an interesting insight. And another box plot right here. So this one, I tried to compare the previous qualification grade. Again, this refers to the scoring that they gave the students before when they applied to the university. So similar to something like an UPCAT grade, for example, this will determine whether or not they will get in the university. And the three outcomes for all of these students, whether or not the students will end up being dropouts, or whether or not the students will end up graduating, or whether or not the students will stay enrolled right here, you can see that there's not really a major difference between their medians. So the median grade of all of the students who end up as dropouts is 133.1. And then the median grade for all of the students who end up as graduates is still 133.1 as well. So it goes to show that the previous qualification grade, that's not really a good indicator for whether or not the students end up becoming dropouts, graduates, or whatever. So that's an interesting insight for me because there might be an expectation that the higher the previous qualification grade is, that they will tend to have more successful outcomes, whether or not they will be drop out, whether or not they will be graduates instead of being dropouts. But this insight right here goes to show the opposite. There's no correlation. It seems like there's no major difference between that. Another interesting insight that I wanted to investigate, I wanted to compare the features, the one I created, total unapproved units, and if that affects the outcome of the student. And unapproved units are basically, again, the difference between the enrolled units and the approved units, meaning some of those units don't end up panning out. Either they get dropped by the student, or they fail that class, for example, or for some reason they don't continue with that one. They drop, or they get a INC. So in the first and second semesters, you'll see that students who end up dropping out from the program, they tend to have a lot of unapproved units for the first and second semester. And if you compare that with a graduate group, they don't really have a lot of unapproved units for their first and second semesters, just between around 0 and 2. And this goes to show that this is a good indicator of what the outcome of the student will be. So if early on the student has a lot of unapproved units, then you can sort of kind of predict that that student might not have very successful outcome. And that's where you would perform your interventions. For example, once you notice that a student has a lot of dropped units, a lot of unapproved units, then your school system, this university, should recommend on providing some kind of help, providing some kind of intervention or assistance to the student to maybe change the outcome. And let's look at this one. Oh, that's just the one I just looked at. This one right here groups the mean grade as well. So the students who end up graduating tend to have higher grades for their first and second semesters, while the students who end up dropping out tend to have lower grades, which is something that we would expect. So I wanted to take a look at that one as well. And here, this one is a scatter plot that compares, we make it full screen, that compares the previous qualification and the mean grade of the student. So you can see that there are three groups right here. This group right here, the majority of the students would end up graduating. This group right here with a low mean grade, these students end up dropping out. And then this group right here, their mean grade is around 6. This is the same distributions that we saw in the distribution chart in the histogram a while ago, the three groups, the trimodal distribution. And there's no indication, there's no trend right here. There's no diagonal line that we can see that shows that the higher their previous qualification is, the higher their mean grade for the first and second semester will be, which supports the earlier insight that the previous qualification grade, it's not really a good indicator for whether or not the student will end up having a higher grade for the first and second semesters. So just goes to show right there. And those are some interesting insights that I found, some interesting um, descriptive insights. I also wanted to check the predictive insights as well by performing some predictions right here. So I just used the logistic regression model. So first, the first thing that I did after performing the data processing, I set the target, and the target column for this one would be labeled as target. And this is the column that contains the categories drop, or dropout, graduate, or enrolled. So those three different classes right there. So that's what I'm interested in predicting. So that is what I will set as my target. And then the next step after that, oh, by the way, I also removed some unnecessary rows. So this one right here would be the row that corresponds to the index. So I don't need that for my predictions. So I just ignored that part. And then after that, I did a train and test split of this proportion right here. 85% will be added to the training portion, and then the rest, the 15% remaining, will be used for the evaluation, for the prediction and the scoring. And then the training data right here, data sample, is sent to the logistic regression model. So I just left this as defaults, the hyperparameters that you see right here. And then the remaining data right there, I use that again for my evaluation. So I fed that into my prediction. So the model that was formed after training right there, I also fed that for on my prediction widget right here. And then I ended up with these predictions right here. And I ended up with these scores. The F1 score is 0.76. The classification accuracy is 0.77, and the precision and recall are around the same as well. So about 75% accurate, about 75% F1 score, which is not bad, better than a coin toss, for example. And I also wanted to see the confusion matrix on what the distribution of the errors are. So if you remember how to interpret this one, and if you want to check how to do that, you can just check the lecture notes on the predictive insights. And you can see right here that 154 were predicted as dropout and 154 were actually dropouts. So the blue ones right here are labeled as the correct predictions, while the red ones are incorrect predictions. So this 26 value right here, this refers to samples, the number of samples that are predicted as dropouts, but are actually enrolled. They're not dropping out yet, they're still enrolled. This one, students who are predicted that will drop out, but actually graduate. So these are interesting. These four samples right here, even if the model predicted them to drop out, they actually beat the odds and ended up graduating. And this is the kind of error that I'm interested in. So the number of samples that are predicted to graduate but actually ended up dropping out. And that's a very interesting um, prediction for me. So, what kind of students are these that they look like they had a successful outcome based on the model, but something happened. They ended up dropping out. So you might be interested in following up on what these samples look like. So I extrapolated from that one using this filter widget right here. I wanted to filter out those that are predicted. So this logistic regression feature right here, this is the prediction. Those who are predicted to be graduate, but at the same time, their actual outcome is that they dropped out. So if those samples qualify, if those samples satisfy these conditions right here, then they will be included in this data set. And you can see it right here. And again, if you're the school system, you might be interested in following up who these students are, students that are predicted to graduate but actually end up dropping out. Like, for example, these students seem to have high enough grades. So these are their grades 13, 15, 13, 12. So you don't really expect them to drop out, but they still ended up dropping out. They don't have they have some total unapproved. So some of them have 5 unapproved units, which goes to show how good of a predictor that is actually. And yeah, those are some interesting insights. Other insights that you can still form out of this, I mostly focused on the numerical or the quantitative features, but you can also look at the features that correspond to the student's background. So you might be interested in the groupings. So for example, I will create a box plot right here and I want to compare, let's say, whether or not they're debtors, whether or not they applied loans for the school tuition, and check their mean grade right here. So students who are debtors, students who applied for loan for the tuition fee for this school, they do end up having lower grades. I mean, and that kind of makes sense as well because students who are um for example poorer, they maybe cannot focus on their studies uh fully. So that's why they don't end up having the best performance. They don't end up having the best outcomes, for example. You can check out the comparison on whether or not courses, which are the most difficult courses out here. So which courses end up having the most amount of total unapproved units. So this course right here, a lot of students probably drop classes. Students who are under the biofuel production technologies, sounds like a complicated program. Informatics engineering, agronomy. So those those programs right there, those courses, they end up having a lot of dropped units. So those are some interesting insights that you might want to look at. So special needs. Let's check the where was that? Total unapproved units and comparing that with the feature scholarship holder, for example. So the scholarship holders, they end up having lesser dropped units compared to the non-scholarship holders. Educational special needs students, there's no meaningful difference from what I look at it. Just a little bit of difference between their distributions, but their mean and their medians are sort of identical. Their medians are both 2. Their mean is around 3.3, 3.5. So having special needs, it's not really an indicator on the on this in this feature right here, total number of units. For grade, it's not an indicator as well. A little higher for students that don't have educational special needs. And so those are the insights that I was interested in for this case study. And you can have even more insights than this. You can check, compare the different programs, the different courses, and how many dropouts those are. To achieve that, you might want to do some group by or some changing the granularity as well by grouping all of the same courses together, etc. Uh, there are a lot of insights that you could be interested in right here. So yeah, and that's basically it. So when you're doing your own case studies as well with the data sets that you chose for your group, you can use this as a guide right here. You don't have to follow everything. You don't have to follow the same insights that I wanted to look at, but you can use this as a guide on what kind of insights that you could look for, what kind of insights that you should dig around with, what kind of data processing that you should do, what kind of features that you can create, etc. So you can use this case study as a guide for your final project slash assessment. And that's basically it for this video. Thank you, everyone.